Select the major product of the following reaction. So if we look at what we are given in this reaction, we can see that we are starting with an alkene. And specifically, we should note that we are starting with an alkene that has the trans stereochemistry. So this is a trans alkene. And then we need to look to see what we are reacting this alkene with. So we see that we are reacting this with methylene iodide. And then we are adding in a mixture of zinc and copper. And so what we're going to need to recognize or remember from the lecture class is that when we mix methylene iodide and zinc copper together, that we are going to get a reagent known as the Simmons-Smith reagent. So it is going to have a structure of an iodine, CH2, the zinc, and a second iodide. And so, as I mentioned, this is known as the Simmons-Smith reagent. And this is a reagent that is known as a carbenoid. Which means a reagent that acts as though it is a carbene. So we can imagine this structure to look a little bit like I-, a methylene with a lone pair of electrons, and then a zinc iodide. And so the portion we're going to be focusing on is this part here, and we're going to imagine that it really is just a methyl carbene. And so when you have a carbene, I'm just going to pull this part out, and I'm going to show it reacting with the alkene. So what you've got here is you've got a carbon that has a lone pair of electrons, so it can be a nucleophile, but that carbon is also electron deficient. We see it only has 2 bonds to hydrogens plus the lone pair, so it can also act as an electrophile. So what happens when it reacts with the alkene is a concerted reaction where the pi electrons of the alkene will attack the carbene at the same time as the lone pair from the carbene attacks the alkene. And so what we're doing here is we are forming, if we follow our arrows, we are forming a 3-membered ring. So I can count 1, 2, 3. And so if we're making a 3-membered ring, this is a cyclopropanation reaction. So we are going to be looking at one of the products where we see that we are forming a cyclopropane, and we're going to pay attention to the stereochemistry. So we can see it started with a trans alkene. So we had the cyclohexane ring pointing in one direction and the methyl group pointing in the other direction. And this is a concerted mechanism. It's all taking place in one step. So that means that this will be a syn addition. It's going to add to the same side. And we're not going to see any rearrangement. So where this was a trans alkene, the 2 alkyl groups pointing in opposite directions, they should still be pointing in opposite directions on your cyclopropane.